Hello everybody, my name is Dave and welcome to my channel. In this video, I will be showing how to compute three integrals that appeared on the MIT Integration Bee in the year 2020. The MIT Integration Bee is a yearly tradition in which MIT students compete to compute tricky integrals. It is run every January and the questions are supplied by MIT graduate students. The MIT Bee is open to all students, although most who participate are undergraduates. The first integral is the natural log of 2x over x times the natural log of x with respect to x. Using a rule from algebra, I can split up the numerator into the natural log of 2 plus the natural log of x. This can be split up into two separate integrals, namely, the integral of the natural log of 2 over x times the natural log of x plus the integral of the natural log of x over x times the natural log of x. It's fairly clear that the natural log of x will cancel out in the second term, leaving me with simply the integral of 1 over x. The integral of 1 over x can be readily computed as it's a standard integral, giving me the natural log of the absolute value of x. Now let's look at the first term of this integral. So I am looking at the natural log of 2 over x times the natural log of x. I can do a u-substitution and let u be equal to the natural log of x. This implies that du is equal to 1 over x times dx. Also, natural log of 2 is simply a constant and it can be pulled outside of the integral. After carrying out the u-substitution, I get the natural log of 2 times the integral of 1 over u du. This can be shown to be the natural log of 2 times the natural log of u. At this point, I have to substitute back in to get this in terms of x. If I do this, I will get the natural log of 2 times the natural log of the natural log of x. This can now be inserted into the first part of our solution. And this is now our final answer. So the integral of the natural log of 2x over x times the natural log of x with respect to x is equal to the natural log of 2 times the natural log of the natural log of x plus the natural log of x. Now let's take a look at the second question. In this question, I have the integral from 0 to infinity of 1 over e to the x plus 1. Recall that whenever we have an improper integral, the question can be restated with a limit. So therefore, I am going to write the limit as b approaches infinity of the integral from 0 to b of 1 over e to the b power plus 1 with respect to b. At this point, I will attempt a u-substitution. I will let u equal e to the b power, and this implies that du is equal to e to the b. This also implies that db is equal to e to the negative b power du, and because we allowed u to equal e to the b power, it also implies that db is equal to 1 over u du. When I carry out the u-substitution, I get the limit as b approaches infinity of the integral of 0 to b of 1 over u plus 1 times u with respect to u. I will now rewrite this in a slightly different fashion in order to allow me to use another substitution further down the line. I will let the integrand become 1 over u squared times the quantity 1 plus 1 over u with respect to u, and anybody can verify that this is indeed equal to the previous line. At this point, I'm going to do another substitution where I let t equal to 1 plus 1 over u. Taking the derivative gives me dt is equal to negative u to the negative 2 power du. And this also implies that du is equal to negative u squared dt. Once I do this substitution, my integral simply becomes negative 1 over t dt. This can relatively easily be found, and once I compute the integral, I get negative natural log of t evaluated at b and 0. What I have now is an answer in terms of t. However, in order to evaluate the limit, I must get this in terms of b. I can recall that t was equal to 1 plus 1 over u. Inserting this wherever I see t gives me the limit as b approaches infinity of the negative natural log of 1 plus 1 over u. I still need to get this in terms of b, and u was equal to e to the b power. This gives me the limit as b approaches infinity of the natural log of 1 plus 1 over b. This can be rewritten as negative 1 times the limit as b approaches infinity of the natural log of 1 plus e to the negative b power. In order to evaluate the limit now, I must evaluate this at the points infinity and 0. Inserting infinity into the first term will give me negative 1 times the natural log of 1, which is equal to 0. And inserting 0 into the second term will give me the natural log of 2. Therefore, the answer to this question is simply the natural log of 2. Let's take a look at the third and final integral in this video. This will be the integral from e to the power of e of the natural log of x times the natural log of the natural log of x over x with respect to x. Once again, I will begin this by doing a u-substitution. U will be equal to the natural log of x, which implies that du is equal to 1 over x dx. I can carry out this u substitution and get the integral of u times the natural log of u with respect to u. Many people will have seen this in their first year calculus textbooks, and we can evaluate this by using integration by parts. So I will allow t to equal the natural log of u. This implies that dv is equal to u times du, and that dt is equal to 1 over u. This also implies that v is equal to u squared over 2. If I follow the integration by parts formula, I will get the natural log of u times u squared over 2 minus the integral of u over 2 with respect to u. I can now evaluate this, and I would get u squared times the natural log of u over 2 minus u squared over 4. I can then substitute back in the natural log of x for u, and I would get the natural log squared of x times the natural log of x over 2 minus the natural log squared of x over 4. I now have to evaluate this expression at the points e to the e power over e. Therefore, I will insert these values into my expression, and I will get the natural log squared of e to the e power times the natural log of e to the e power all over 2 minus the natural log squared of e to the e power over 4 minus the quantity the natural log squared of e times the natural log of e over 2 minus the natural log squared of e over 4. Recall from algebra that the natural log of e is simply 1, and that the natural log of e to the k is simply that number k. Therefore, the natural log of e to the e will simply be e. And recall also that the natural log of 1 is equal to 0. If I do these calculations, I would get e squared over 2 minus e squared over 4 minus 0 minus 1/4. Simplifying this gives me e squared over 4 minus negative 1/4. Simplifying this even further gives me e squared plus 1 over 4, which is our final answer. Thanks everybody for watching. I hope you enjoyed this video. If you like this, please click like and subscribe. Thank you very much.